In this presentation, we are going to learn about the energy of the simple harmonic oscillator. Simple pendulum is the best example of simple harmonic oscillator. In the case of simple pendulum, it is oscillating with respect to its mean position. Look at the movement of the pendulum. I have drawn one dotted line in the middle. With respect to the mean position, it is oscillating here and there in to and fro motion. Nearby, one energy graph is given. Look at the variation in the energy graph. The oscillating pendulum, that one possesses both kinetic energy and potential energy. If you add both, if you sum up both kinetic energy and potential energy, you will get the total energy of the oscillating system. Look at the variation in the kinetic energy and potential energy. Sometimes kinetic energy, it reaches the maximum, and sometimes the kinetic energy, it is dropping down to zero. Sometimes potential energy is maximum, sometimes potential energy becomes zero, but anyhow the total energy of the system remaining same. Whatever may be the nature of the energy, the total energy of the oscillating system will be constant. So with the help of this simple simulation, we are going to learn where the potential energy is maximum, where the kinetic energy is maximum, where the potential energy is zero, where the kinetic energy is zero, and we are going to learn how the total energy of the system remaining same. So all those things to be learned one by one. I am going to keep the bob at rest at various positions. I am going to explain. Now I am going to bring the bob to the left extreme end. Look at here. Further, if it is moved, I am going to bring the bob at rest at somewhere else. Look at here. Now the bob is at right extreme. Simultaneously, you have to look at the energy graph. In this position, in the right extreme end, the bob, it takes rest. Momentarily it will be at rest. The kinetic energy is zero. Because velocity is zero, therefore kinetic energy is zero. And the bob pendulum will have maximum potential energy. If you add the kinetic energy and potential energy, you will get the total energy. The total energy will be fully contributed by potential energy. Look at the bar also. Potential energy bar is shaded with bluish shade, and the total energy is also shaded with bluish shade. It shows that the total energy is fully contributed by potential energy. Now I am going to oscillate the pendulum further, and when it is oscillating, I am going to bring the bob pendulum to the right extreme. Look at that. Look at here. Look at the graph. Even in the left extreme, which energy is maximum? Potential energy is maximum. Kinetic energy is zero. No bar is seen in kinetic energy. Potential energy bar is fully shaded. So it shows that kinetic energy is zero. In the meantime, you have to understand that the bob, it is momentarily at rest. Pendulum is not moving in the right extreme end. If you add both kinetic energy and potential energy, you will get the total energy. The total energy is fully contributed by potential energy. Look at the potential energy bar and total energy bar. Both are shaded with bluish line. Now I am going to oscillate the pendulum further. Now we will analyze what happens in the mean position. Look at here. I am going to bring the pendulum exactly in the mean position. Look at that. We will make it oscillate. Only then we are able to analyze. We'll allow it to oscillate. Look at here. We'll try to bring it exactly in the mean position. Look at here. Now, when it crosses the mean position, the bar will have maximum velocity. Since it is having maximum velocity, kinetic energy will be maximum, potential energy will be zero. So the total energy is a sum of kinetic and potential energies. So here potential energy is zero. So the total energy is fully contributed by kinetic energy. Look at both the two energy bars. Kinetic energy bar is shaded with greenish color and total energy bar is also shaded with greenish color. It shows that the total energy is fully contributed by kinetic energy. Now I am going to bring the bar in the intermediate position. Look at that. Look at that. Here in the intermediate position, the total energy is contributed by partially kinetic and partially potential. Are you clear? So the total energy is a sum of kinetic and potential energy. So before reaching the right extreme in the intermediate position, the energy possessed by the oscillator, total energy possessed by the oscillator will be partially potential and partially kinetic. You can see both greenish shade and bluish shade in the total energy region, total energy graph. Okay. Look at here. Look at here. Now also, when it tries to reach the right extreme, there also the energy is partially kinetic and partially potential. This is one of the intermediate positions. Okay. So you have to understand one thing, that only in the left extreme end and right extreme end, the bar will have maximum potential energy and kinetic energy is zero. In the intermediate position, the energy is partially kinetic and partially potential. When it reaches the mean position, how the energy will be? The energy will be fully kinetic. The total energy will be fully kinetic. Potential energy is zero. Okay.